Last chapter review we'll be starting with number 70, and here they're mixing up the problem. They put some in order, some they mix. So I picked and chose some different combinations to touch on everything. So glancing at this, you might be thinking, well, what should I try? You should try a U sub every time. If not writing it out, at least in your head. That is, what do you take a derivative of to get x squared? You take a derivative of x cubed. So it works. If you let u equal x cubed, du is 3x squared dx. So there it is. There is my du. The 1/3 I'm going to pull up front. And there's an e and a u. And if I put a 0 in there for x squared, that becomes a 0. And if I put a 1, that happened to match, because that's a unique point. So now I don't have to go back to x, and that will be 1/3 e to the u evaluated from 0 to 1. And that would be 1/3 into e to the 1 minus e to the 0, which is 1. And there it is. So I should try a u sub every single time. I glance at this problem, and I notice that this problem has a cosine, and the cosine has an even power. There's only one way of proceeding, and that is power reduction. 1 plus the cosine of double the angle. What's double 2x? 4x. And that would be 1/2 times the integral of 1 is dx, and the integral of dx, if of 1 dx, is x. And what do you take a derivative of to get the cosine? The sine of 4x, and we divide by 4, evaluate from 0 to pi over 4. That will be 1/2 pi over 4. If I throw pi over 4 in there, 4 times pi over 4 is pi, and the sine of pi is 0. And if I substitute 0 in, I'll get a 0 plus 0. So basically there it is. The answer is really pi over 8. So when I glance at a problem, I try to identify what kind is it. Is it a U sub? If not, well, what does it have in it? And let's look at this one. Here, this doesn't match anything that specific section, so I do notice there's a square there. Now I could say that's e to the 2x plus 1 over e to the x, get a common denominator and proceed, or I could FOIL. And I notice foiling works. If foiling works, no need to take a different route. And this would be e to the 4x divided by 4. This is 2e to the x, and this is mine, or I should say plus e to the minus 2x divided by negative 2 plus c. And there it is. Next problem up is number 80. And I'm glancing at this and I'm debating, thinking, well, okay, what should I let u equal? I could let u equal, and again, I'm looking at dv or du. The problem with this is that I want du to be a dx because there's a plus 1. So if I let u equal e to the x, okay, that seems to be okay, because this is, I could say, there is u, that would be u squared minus 4, that will be u, and I know if I take a derivative, I'll get e to the x dx. I could have saved it for this, but we have a number floating around which prevents me from doing that. So what I'll say, you know what, let this be u plus 1, and in this sense, I want dx to be, I want to take a derivative and just get the x. And how do you do that? You solve for x. X would be natural log of u. And now if I take a derivative, I'll get 1 over u du. It doesn't matter how messy this is. What matters is, can I get that to match? And I did. It's really this. It is 1 over u du. So basically, I'm looking at the integral of u plus 1 over u squared into u minus 2 into u plus 2. So I know what this is. This is partial fraction decomposition. So let me work that out. So basically, I'm going to move this. I'll bring it back later. And now, I would say u plus 1 over u squared into u minus 2 into u plus 2 equals, that would be a over u plus b over u squared plus c over u minus 2 plus d over u plus 2. If I clear the fractions, b times u minus 2 into u plus 2, that could be u squared minus 4, right? Just short it to right. Plus c u squared into u plus 2 plus du squared into u minus 2. And 3 values I could choose. U equals 0, 2, and negative 2. If let u equal 0, I'll get a 1 equal. That's a 0. B times a 0 there, that will be a negative 4. A 0 and a 0. So that makes this negative 1/4. Now if I let u equal 2. 2 plus 1 is 3. 2 in there will make that a 0. A 2 in there will make that a 0. A 2 in there will make that c times 2 squared times 2 plus 2, which is a 4. And a 2 there will make that a 0. So this is saying 3 equal, what is that? 2, 4, 2, you know what I was thinking. I was thinking of a 4 and I wrote a 4 instead of a 2. So that is 2, 4 times 16 c. That means c is 3 over 16. And if I let u equal negative 2, I will get a negative 2 there, a negative 1, a negative 2 there will make that a 0, a negative 2 there will make that a 0, and a negative 2 there will make that a 0. That will be d negative 2 squared times minus 2 is a negative 4. That means d is, and let's see, this is for negative 16, negative 1 over 16. Now I know this is negative 1 over 16, and I know that c is 3 over 16. And now if I choose a value, I chose 0, 2, and negative. What if I let u equal 1? And if I let u equal 1, and again I'm talking about this equation. So if I plug 1 in there, that will be 2 equaling, a is what I'm looking for, times 1. 2 minus 1 is negative 1. 2 plus 1 is 3. Minus 1/4 for b. If I put a 1 right there, that will be negative 3. Plus 3 over 16. If I put a 1 in there, that will be a 3. Minus 1 over 16. And if I put a 1 in there and a 1 in there, that will be 1 squared and a negative 1. So I just want to solve that equation, and pretty much I'm done with the problem. That is negative 3a plus 3 over 4 plus 9 over 16 plus 1 over 16. LCD is 16. So LCD is 16. If I clear the fractions, 16 times 3, 48. 4, top and bottom, that's a 12. Okay, too many equals. 9 plus 1. So this says 32 equals negative 48. 9, 10, 22. So subtract, that's 10 equal negative 48. A divided by negative 48. And I get A to equal a negative divided by 2, that's a 5, divided by 2 is 24. Hopefully I didn't make a mistake, but you get the idea of how that works. Negative 5 divided by 24. So all of this work is for me to be able to write this as negative 5 over 24 divided by u minus 1 over 4 over u squared plus 3 over 16 over u minus 2 minus 1 over 16 over u plus 2. All of that du. So how does it work? I know there are 3 logs in there. Minus 5 over 24. This is natural log of u. This piece, I'll come back to it in a minute. This piece is 3 over 16 natural log of u minus 2. And this piece is minus 1 over 16 natural log of u plus 2 plus c. That would be my final answer. I should have used a different color. I didn't realize it's going to be this long. And let's see. Don't forget what was u. U was e to the x. The integral of u to the negative 2 is add 1 to the power divided by that. And there it is. Okay, next problem up, number 90. So I'm glancing at that. I notice this is an improper fraction. So what I need to do the algebra. I need to take x cubed plus 2 and divide that by negative x squared plus 4. If the negative is bothering you so much, you could factor a negative out. I'm not going to do that. But if it's bugging you so much, you could do that if you wish. I'm just going to keep that problem as is. You can do whatever you like. X cubed divided by negative x squared is a negative x. When you multiply, you get positive x cubed minus 4x. Subtract. And that would be it. So this is the integral of negative x, and the remainder is 4x plus 2 divided by 4 minus x squared. That is, I could factor a 2 out of the top, but that wouldn't help, because that would be 2x plus 1. That is a over 2 minus x plus b over 2 plus x. And if I clear the fractions, and 2 values, and I'm done. Let x equal 2 and let x equal negative 2, and there's the problem. Let x equal 2. A 2 in there will make that an 8, that's a 10 equal. A 2 in there will make that a 4, and that's a 0. That means a is 10 over 4, which is 5/2. And if I let x equal negative 2, negative 8 plus 2 is a negative 6. That's a 0. And a negative 2 there will make that b times 4. And that would mean that b is negative 3/2. So basically, there's a price for not taking the negative out, but factor a negative, you might not have to suffer as much, but it's not that big of a price. So the integral of this would be natural log of 2 minus x. You divide by a negative 1, so you make that a minus. And the 3/2, that will be natural log of 2 plus x plus c. And that would be my final answer. Okay, the next problem, number 92. So, looking at this problem, a u sub doesn't do it. And I notice there's a radical, and it's very hard to manipulate the radical, because even if I let u equal the whole radical, square both sides, du can never be a dx. It's going to have an extra x in there. So, one way of proceeding, take negative 2x minus x squared, factor a negative out because you want to complete the square. So, I'm going to add a number, and I'm going to subtract that number. Since this number is being multiplied by a negative 1, I must multiply this by a negative 1. What if you decided not to factor a negative out? Then you can't complete the square, so it's not an option. Take half of the middle number, which is 1, and square it, that's a 1. So this is pretty much reads negative x with that sign, the number before I squared it, and a plus 1. So this is the integral of dx over the square root of 1 minus x squared plus 1 squared. Now, if I look at my substitutions, my trig substitutions, oh, that's an arrow, okay. There we go, better. So, normally it says, take the square, let that square equal, in this case, 1 minus the sine of theta. You could look up, that's provided on your test. dx is the cosine of theta d theta. This becomes the integral of dx is right there. Square root of 1 minus, and if I replace a sine of theta and I square it, now, wouldn't the square root of 1 minus sine squared of theta be the square root of cosine squared of theta? Would be simply the cosine of theta. So this says it's, okay. This says it's going to be the integral of cosine of theta over cosine of theta d theta. Those cancel out. Wouldn't that simply be theta plus c? And I go back to my original substitution. If I let sine of theta equal that, wouldn't theta be the inverse sine of x plus 1 plus c? Now, I am providing a derivative for you on the formula sheet. If you glance at your formula sheet, I did provide that derivative. So what do you suppose the integral of dx over 1 minus x plus 1 squared under the radical would equal? So you really should avoid doing that if you could, but if not, there it is. You could do it the, long way. That could happen. But if you could recognize it, then you should. Oh. Okay, next problem up. Again, a u sub wouldn't do it. If I let u equal this, du will be 3x squared, 3x, and I can't solve for x. So, I'll write out the obvious. This is really x minus 1 squared and x cubed dx. Now, I could manipulate the problem by the new technique of the u sub to switch the order. Keep in mind, a over b plus c is not pleasant. D plus e over m, that I could split. I could say that's d over m plus e over m. So if I let u equal x minus 1, I notice automatically if I take a derivative, I'll get a dx right there. And that's really what I want. So du is dx, so I really was able to write this as u squared. There's a small price for it, of course, there's a cost for everything. But I still have this x left. I'm not sure what to do with that. Well, guess what? Right, that's du. What does x equal? Isn't x equal to u plus 1? Now the price here is not a big price, is you to distribute this out. So basically this is the integral of u cubed over u, 3u squared over 3u squared, so I'm using the sketch, 3 over u and 1 over u squared du. And that would be u squared over 2 plus 3u plus 3 natural log of u minus 1 over u plus c. And do remember what u represented. U was, if you go back up there, it was x minus 1. And there it is. And I have a couple more to go. And let me just... (108) Well, I know exactly what to do with an inverse trig function or log. I always let u equal that. No exception. If du will do it, you're in good shape, but du doesn't do it. It's 1 over plus x squared plus 1. So that means parts dv must be whatever's remaining. And if you integrate, v will be negative 1 over x. So this is going to equal u times v minus the integral of v du. This is going to equal negative inverse tangent of x over x. And 1 over x into x squared plus 1 equals a over x plus bx plus c over x squared plus 1. Clear the fractions. And let x equal 0. I'll tell you what. I want to do all of this work up there. Let x equal 0. So I'll get 1 equaling a plus 0. So a is 1. That's going to save me some work. Now here, you have two options. Either you clear the fractions and use the Book's technique. By having this equal 1, you'll get to the answer in no time. Or you could let x equal maybe 1 and negative 1, two values. So if I did the Book's method, 1 equal x squared plus 1 plus bx squared plus cx. 1 equal b plus 1x squared. And again, as you see, just by having the 1 there, automatically you clear things out. The number in front of x squared must equal, but there's no x squared. That means b plus 1 must equal 0. That means b is negative 1. And the number in front of the constant must equal the constant. Okay, I did put an x. A plus b plus cx plus 1. So the number in front of x is a 0. And there it is. So this is actually the integral of 1 over x minus 1 over x squared plus 1 dx. That would be negative inverse tangent of x over x plus natural log of absolute value of x minus the inverse tangent of x plus c. Well, here I see a bunch of radicals. I have a couple of options. So the first option is to work a step at a time. So you know what? Let u equal the square root of 1 plus x. Since there's only a dx, I need to get rid of the radical. And if I take a derivative now, you will say that is 2u du. You've just transformed the problem into 1 plus u, and the x is actually twice du. Now, do you see that this is simply whatever this is, add 1 to the power, divide by that? Of course, you could leave it as 3/2. You really don't have to write it the way I'm doing that. I'm just trying to impress you. And wasn't that just the square root of 1 plus x? And I've seen students do this. They let it be the whole thing. And they do the same idea. They square both sides. And they keep on saying, but I still need to solve for that x. So they subtract 1 from both sides. And they square both sides now. And now they take a derivative. And they say, this is the integral. Here they chose u to be the entire integrand. And the x is actually dismissed. So as you see, a 2 up front, 4 up front, not 2, 4 up front. And u times u is u squared into u squared minus 1, right? And that is 4 times u to the 4th minus u squared. That is 4 times u to the 5th over 5 minus u cubed over 3 plus c. And what's u? U is all of that. Oh boy, I didn't realize it was that long. That I should say. That is the square root of 1 plus square root of 1 plus x. And this was a minus, I believe, yeah. And that is the square root of 1 plus the square root of 1 plus x. And there's the homework.